Hello students, today we will see the graphical representation of zeros of linear polynomial ax plus b. Students, we know how to plot graph as a part of coordinate geometry. So today let's plot the graph of linear polynomial and find out its zeros. So let's start with the simplest polynomial, the linear polynomial. We already know that linear polynomial has its highest degree as 1. We will observe that the graph of linear polynomial is straight line, because of which we call it as linear graph. Students, recall, y-axis of graph represents our polynomial p of x, and the points on this axis are nothing else but the values of p of x that we get when we take different values of variable. So in other words, when we take different values of variable, that is x coordinates, we get corresponding values of polynomial as y coordinates on y-axis. Thus we can say that x is independent, and since values of y are derived from x, it is dependent on x. Now to get these coordinates, we have to convert polynomial to polynomial equation of the form y equal to p of x. So let's start. Take linear polynomial, say p of x equal to x, and plot the graph of this polynomial. But as you know, for plotting graph, we need pair of coordinates. And to find out coordinates of polynomial p of x equal to x, we have to convert polynomial to polynomial equation of the form y equal to p of x, which gives us y equal to x. And by assigning different values to variable x, we get different coordinates. Student, you will observe that since x and y are equal, the value of y will same as that of x. You can see when we take x equal to -2 and put in equation and solve, we get value -2, which is our y coordinate. Similarly, if we take x equal to -1 and put in equation and solve, we get value -1, which is our y coordinate. And similarly, we can find coordinates of other points also. Now plot these coordinates. Say point A has coordinate -2, -2. Point B has coordinate -1, -1. Point C has coordinate 0, 0. Point D has coordinate 1, 1. Point E has coordinate 2, 2 on the graph paper. Now join these points. You observe that graph is a straight line and passes through the origin point O with slope going upward to the right. We know that in the graph, 0 of polynomial is the point where graph cuts the x-axis. In other words, it is the x coordinate of that point. Now here you can see graph cuts x-axis at origin, that is 0. Therefore, 0 is the 0 of this polynomial p of x equal to x. Now, if we take y equal to -x, that is after changing the variable from positive to negative and obtain the coordinates, you will see that y coordinate obtained is the additive inverse of x coordinate. You can see when we take x equal to -2 and put in equation and solve it, we get value 2, which is our y coordinate. Similarly, if we take x equal to -1 and put in equation and solve it, we get value 1, which is our y coordinate. And similarly, we can find coordinates of other points also. Plot these coordinates on graph just like our previous case and join them. The graph, as you can see, is still a straight line, but with changed slope. In other words, slope goes downward to the right. However, it still passes through the origin O. We know that in the graph, 0 of polynomial is the point where graph cuts the x-axis. Now here you can see graph cuts x-axis. Therefore, 0 is the 0 of this polynomial p of x equal to -x. Thus, if one of the zeros of polynomial is 0 itself, then graph of such polynomial will always pass through the origin. Students, what you have to note here is that if you change the sign of leading coefficient, then the shape of the graph will be same, but just change the side. This is true for other polynomials also. Now let us take one more polynomial. Say 2x plus 5 and obtain the coordinates by converting it to y equal to 2x plus 5, which is y equal to p of x form. You can see when we take x equal to minus 2 and put in equation and solve it, we get value 1, which is our y coordinate. Similarly, if we take x equal to minus 1 and put in equation and solve, we get value 3, which is our y coordinate. And similarly, we can find coordinates of other points also. Plot these coordinates on graph. You will see that graph is straight line. But now the graph is not passing through the origin, which means that none of the coordinates are 0 and 0. This means that 0 is not a 0 of this polynomial. But see where the graph intersects x-axis? Yes, graph intersects the x-axis at minus 5 upon 2. This means 0 of the polynomial 2x plus 5 is minus 5 upon 2. What else does this graph tell us? Graph also tells us that with the change in the value of the variable x, how the value of polynomial p of x vary. Did you observe that in all cases of linear polynomial, there is only one zero of the polynomial? Yes, linear polynomial will always have unique zero. We will see later on that a polynomial can have more than one zeros also. As an exercise, try your hands by representing linear polynomial 8x minus 3 graphically and find out its zero. Let's revise. Linear polynomial is represented as ax plus b. Graph of linear polynomial will always be straight line. Zero of polynomial is the point at which graph cuts x-axis, and linear polynomial will always have one and only one zero. In the next video, we will see graph of quadratic polynomials.